Merion. This is our pandemic era version of One Book, One Lower Merion. Ordinarily, we would all be together in the Board of Trustees room at the Township Building, meeting with our author, having an opportunity to purchase the author's books. But of course, at this point in history, we're not doing that. However, we are very blessed to have with us the author of this wonderful book, You Bet Your Life. It's not Groucho Marx, just as a hint. It's Dr. Paul Offit, who is a star, not only in the Philadelphia area, but all over the country, and in fact, all over the world. When you hear that the FDA Committee on Vaccines has made a decision, Dr. Offit is a member of that committee, and he speaks out. He is passionate. He's passionate about pediatrics. He's passionate about vaccines. He is, in fact, a professor of pediatrics, and let me get it right, vaccinology at the Penn School of Medicine. He has written many books, and for those who have read this book, you may remember that he also wrote a book a few years ago, and that too was a One Book, One Lower Merion choice, Pandora's Trump. Wasn't that it, Dr. Offit?
Pandora's Lab. But yeah.
Lab. I knew I had that wrong. I can picture the green cover. We use green. But in any case, he has the wonderful ability to write a nonfiction book that moves and is interesting. And I have to tell you, I couldn't put it down. I finished it in one day. I thought it was a terrific book, and you learned as you read, and he appealed to your intellect, he appealed to your sense of humor, and today you're going to have the opportunity to hear him. Dr. Offit, welcome to One Book, One Lower Merion, and I hope you'll enjoy talking to our audience and getting the questions this afternoon.
Thank you, Lenora. So what I'm going to do is I'm not going to have slides. I'm just going to speak for maybe 15 or 20 minutes or so, and then leave plenty of time for your questions. So what this book is about is making decisions under uncertainty, which we do all the time. I think we prefer not to think about it, but we do it all the time. And one of the early chapters I have is about blood transfusions. So I try to sort of stop at various intervals of as we learn, because we always learn as we go. There's always a learning curve. I think people would like to think, you know what, let me just wait till the learning curve is over and then I'll try that medical innovation, but it never works that way. The learning curve is pretty much never over. But taking blood transfusions as an example, the first blood transfusions for people were done in the 1600s. The source of blood was barnyard animals. And not surprisingly, people who received those transfusions had immediate transfusion reactions because obviously there's a blood type mismatch. We didn't know anything about ABO blood typing yet. But they actually, after having fever and chills and darkened urine, actually they didn't do that badly, the few people that got those transfusions from barnyard animals. Okay, so then you move to the early 1900s when Karl Landsteiner actually figures out ABO blood grouping. So would you get a blood transfusion then? Realizing that we still didn't know about Rh blood, that particular blood type. So if you're O positive, it's the positive part. Okay, so now you know that. Now you know about ABO blood typing, you know about Rh blood typing. You're in the say, let's say the mid 1900s, let's say 1940, 1950. Would you get a blood transfusion then? So what we didn't know about was the fact that certain viruses could be in blood, like hepatitis B virus, or what was originally called non-A, non-B hepatitis, which is now called hepatitis C virus. And those infections could cause a severe, acute, and occasionally permanent and overwhelming problems. Okay, so now you're in the late 1970s. You can identify hepatitis B virus. You can identify hepatitis C virus. Would you get a blood transfusion in the late 1970s? So what comes into the blood supply in the late 1970s? HIV, which was overwhelming. I mean, thousands and thousands of people died from blood transfusions. The canary in the coal mine, always true for blood transfusions, are adolescents with hemophilia. And so Ryan White probably being the best example of someone who was overwhelmed ultimately by a blood transfusion that was contaminated with HIV. Okay, so now you're today. Would you get a blood transfusion today? Knowing that there are viruses we don't test for. You don't test for Epstein-Barr virus, which is the cause of mono. You don't test for cytomegalovirus, which can cause problems. You don't test for West Nile virus. Unfortunately, SARS-CoV-2, by the way, is not a bloodborne virus, so that's not a problem. But so there's always risk. And so then, would you want to be one of the first people to try an artificial blood? I mean, artificial blood is now being worked on in the lab, where you can make these little, cells or cell-like material that that contains hemoglobin that, in theory, can transmit oxygen and carbon dioxide. Would you try that? So it's always a matter of making choices under uncertainty. And so to give you other examples of that, if you're one of the 4,000 people currently on the heart transplant waiting list, know that 1,300 of those 4,000 will die while waiting. So do you want to be one of the people who gets a pig heart, knowing that just in the last few weeks, there was a successful recipient of a pig kidney? You can genetically engineer pigs so that you are much less likely to reject that organ. Your immune system is less likely to reject that organ. Would you want to be one of the first people to try that? Or how about CRISPR technology? CRISPR technology is a gene editing system. I mean, you can take someone's, say, bone marrow, remove it, edit the cells in that bone marrow, and then retransfuse them back into that person. So if you're someone who has a single gene disease, like sickle cell disease or cystic fibrosis, diseases that shorten your lifespan, so that instead of living 70, 80 years, you live 40 years, 30 or 40 years. Would you want to be one of the first people to try that? Recently, there was a woman who had sickle cell disease, who was one of the first to try this gene editing system, and she's now lived for 2 years after having had that gene editing of her bone marrow cells. I mean, normally she would go to the hospital 4 times a year, 5 times a year, with so-called vaso-occlusive crises, which are painful crises requiring hospital admission, requiring powerful anti-pain medicines. Would you want to do that? And it's just because you learn as you go. The gene editing systems, for example, I'm at the University of Pennsylvania, and most of you, I'm sure, remember the death of Jessie Gelsinger. I mean, Jessie Gelsinger was a 19-year-old man who had an enzyme deficiency, which had the fancy name ornithine transcarbamylase. So he had trouble converting food to energy, and that resulted in a buildup of ammonia in his bloodstream. The same kind of ammonia that you use to scrub floors with. And so periodically he would lapse into a coma and have to go to the hospital because he had a very tough dietary regimen that also included him taking 30 pills a day, which is hard for a teenager. And so therefore he volunteered for Jim Wilson's gene therapy, where what was done was Jim Wilson took something called a replication defective adenovirus. It's the exact same thing as Johnson & Johnson vaccine. In fact, it is the same thing as Johnson & Johnson vaccine, which is also a replication defective adenovirus, into which was cloned then the gene that Jessie Gelsinger lacked. And he transfused that into Jessie Gelsinger, and within a few days he died. And it was only later that you figured out what he had died from. And what he died from was basically an overactive immune system, where he was making this particular protein called interleukin-6. And even if Jim Wilson had known that at the time, even if the doctors at HUP had known that at the time, it wouldn't have saved his life, because we didn't yet have a monoclonal antibody directed against that protein. We have it now. And because of what Jim Wilson found out with that death, was that then when a little girl named Emily Whitehead at Children's Hospital of Philadelphia, who had leukemia, a leukemia that had relapsed and was resistant basically to chemotherapy. I mean, she was not going to do well. So what Carl June did at the University of Pennsylvania is he took a particular kind of immune cell called T cell, killer T cells, engineered it to kill her leukemia cells, transfused that back into her, and she had the same reaction that Jessie Gelsinger had. And he and Steve Grupp and others at Children's Hospital of Philadelphia realized that. But now there was a monoclonal antibody against that interleukin-6. And so they saved Emily Whitehead's life. And if you go to like the gene therapy center at Penn, at CHOP, you'll see Emily Whitehead's picture all over the place. I mean, she was on NBC's Today Show. She was taken to the White House and feted by President Obama. But what you don't see hanging anywhere is the picture of Jessie Gelsinger. But you don't get to Emily Whitehead. You don't get to save Emily Whitehead's life unless there's someone like Jessie Gelsinger. Because, and as I talk about in the sort of 9 stories in this book, which are all about, sort of the major advances in medicine, whether it's anesthesia or antibiotics or vaccines, is that the history is invariably littered with tragedy. As Michael Harris said, the history of drug regulation is built on tombstones, and that's true. You learn from your failures, but just because Jessie Gelsinger's picture is nowhere because we're uncomfortable recognizing our failures, but we're very comfortable sort of celebrating our successes. Okay, so just to sort of continue, as Lenore alluded to, I'm on the FDA's Vaccine Advisory Committee, so we are asked to, again, make decisions under uncertainty. So recently, just on October 26th, our committee of 18 voting members had to consider a vaccine for 5 to 11-year-olds, a SARS-CoV-2 vaccine, a COVID vaccine for 5 to 11-year-olds. The study that we looked at included 2,400 children. 1,600 got vaccine, 800 got placebo. The vaccine was 91% effective at preventing COVID. That's only 2,400 children. I mean, we are making a decision. How many 5 to 11-year-olds are there in this country? About 28 million. So you're making a decision for 28 million children based on a study of 2,400 children. So it's nerve-wracking. I mean, because the question is never when do you know everything. It's when do you think you know enough to move forward. And when we made that decision, I got a lot of pointed, and that's a nice way of saying it, emails from parents saying, really, 2,400? I mean, when Pfizer did its trial of adults, that was a 40,000 person study. And you're telling me that for the 5 to 11-year-old, you're willing to accept a 2,400 child study? Really? To which my response was, because there were 16 cases of COVID in that study, in the placebo group. There were 3 in the vaccine group. And the 3 in the vaccine group were very mild, but the 16 in the placebo group weren't. Those kids all had fever and were pretty sick. So my response to that is, okay, so we don't have to do a 2,400 child study. Do a 24,000 child study. In that case, there wouldn't be 16 cases in the placebo group. There'd be 160. I mean, what price suffering? I mean, or what price knowledge? What human price do you want to pay for knowledge? And the one of the reasons I wrote this book, actually, as a child of the 1950s, I was a first and second grader in the 1950s. I mean, I lived through the development of the polio vaccine, and I remember that. I was a 5-year-old. I was actually in a polio ward for about 6 weeks, so I certainly remember polio. I remember what polio looked like. I remember children in iron lungs. I remember children in traction. I was in I grew up in Baltimore, and I was in a hospital currently called Kernan Children's Hospital. Then it was called Kernan's Hospital for Crippled Children, because that was back in the days when you could use words like crippled and feeble-minded to describe hospitals for children. It's when Jonas Salk made his polio vaccine in the 1940s and 1950s, what he did was he took polio virus, grew it up in cells, purified it, and killed it with a chemical. It was a whole killed viral vaccine. He then tested it in 700 children in the Pittsburgh area and found that the vaccine was safe and that it induced an immune response that he believed would be protective. So he goes back that night to his wife, Don, and says, Eureka, I've got it. That was it. As far as he was concerned, he made a polio vaccine. And then what was about to happen was something he didn't want. He didn't want to do a test of his vaccine. He could not conscience giving placebo to children in the 1950s, knowing that every year there would be 20 to 30,000 children who would be paralyzed by that virus, and knowing that every year there'd be 1,500 children who would die from that virus. Nonetheless, the then called National Foundation for Infantile Paralysis, otherwise known as the March of Dimes, did what was then, and I think remains today, the biggest test of a medical product. What they did was they gave 420,000 children Salk's vaccine. They gave 200,000 children placebo, saltwater. And then watch what happened over the next year. When it was over, the person who headed that program was a man named Thomas Francis out of the University of Michigan. And so he stood up at the podium at Rackham Hall at the University of Michigan and said those 3 famous words: safe, potent, and effective. Those words were on the headline of almost every newspaper in this country. It was church bells rang out, synagogues held special prayer meetings, department stores stopped to make that announcement. The Voice of America announced that over the loudspeaker to the world, to Europe and the world. I remember my mother crying when that announcement was made. So how do we know it was effective? We knew it was effective because 16 children died from polio in that study, all in the placebo group. We knew it was effective because 36 children were paralyzed in that study, 34 of the 36 in the placebo group. That's how we knew. I mean, those were first and second graders in the 1950s. I was a first and second grader in the 1950s. But for the flip of a coin, those children could have lived long and fulfilling lives. And I just think that's one part of this that never is quite appreciated, which is the price, the human price of knowledge. So, okay, now that I've completely depressed you, I'm just going to stop and take any questions you have about anything related to this book or anything otherwise. I have a feeling COVID or COVID vaccines might creep into these questions, but I'm happy to answer any questions you have. Don't be shy. Come on, this does not look like a shy crowd. I see a lot of faces out there, and those are not shy faces, especially people who are older. People my age are not shy.
His face.
Yeah, well, this is not relevant because the audience doesn't see it. Okay.
First of all, let me say hi to Ted Tapper. I see you out there, Ted. Good seeing you. I talk to your son periodically on TV, so we talk about the Eagles actually a lot.
First question, what is your advice on reliable sources for average readers, non-doctors, to cull out the misleading and politicizing of scientific information? Even supposedly reliable sources can misconstrue the information. What do you suggest reading to get a balanced and accurate view?
Well, I mean, regarding these vaccines or this disease, I think, places like the Centers for Disease Control and Prevention, hospital or university-based sites. I mean, the Vaccine Education Center at Children's Hospital Philadelphia, I think, is a reliable site. So you just have to be careful. I think that when you look on the internet for information, the internet is a great source of wonderful and awful information, which can be really helpful or incredibly misleading. And the trick is trying to find ones that you trust. I do think that university-based groups or groups like the CDC, groups that frankly you should never, I think, trust a site that's also selling something as a general rule. But it is confusing. I think part of the problem also is that we learn as we go with this virus. We do. I mean, Dr. Fauci is a star to me. I mean, I think he's a wonderful public health official, but he has said some things that ended up not being true. I mean, he was generally not terribly supporting of masking initially, the thinking being, especially with those sort of rectangular masks, like surgical masks that you can sort of breathe in and out through the side, and certainly viral droplets containing viral particles can enter. So, but over time, it became clear that especially like the KN95 mask and other masking was clearly effective, and people hammered him for that. And I think it's the problem with science is it's fluid. And I think that fluidity is disconcerting. I mean, we will take textbooks and throw them over our shoulder without a backward glance as we know more and more. But that makes people uncomfortable. And so you tend to be drawn to the guru, people who don't express doubt, like Deepak Chopra, for example. It's what I call sort of the Bones Mccoy seduction. I don't know if you remember Star Trek, but there was this chief medical officer was Bones Mccoy, and he had this tricorder that he would always hold in his hand. And if you had signs or symptoms of a particular illness, he would sort of scan you up and down, and then he would look at the readout, and that's what you had. That's very reassuring. Medicine doesn't actually work that way. There's a lot we don't know. There's a lot we can't do, and that is upsetting for people. I think if you ask this audience, do you think we're going to know more about science, more about medicine 100 years from now than we know now? I'd like to think everybody would say yes. But when it comes to your illness, you would like to believe we know everything we need to know right now, when that's often not the case. And that fluidity is difficult. I can tell you, I was trained at Children's Hospital in Pittsburgh for the 3 years in the late 70s as a pediatrician. And I learned things that were wrong, dead wrong. I mean, I'll give you an example. I learned that after a baby feeds, that you should lie the baby on his or her stomach so that the child will not aspirate, bring down into the windpipe and ultimately lungs the food that he just ate. That was wrong. That was bad information. And in fact, that increased the risk of sudden infant death syndrome. And so in the early 1990s, a decade after I trained, you then learned to put the child on his back, the so-called back to sleep program. And that dramatically reduced the incidence of SIDS. That's just one of several examples. We used to treat febrile seizures with phenobarbital for a long period of time. Bad idea. So I just think we learn as we go. It doesn't mean you can't trust science. It just means that science is circumspect. It's self-correcting. That, in fact, to me, that's why you can trust it. But you have to realize that. And that's also part of this book, is realizing that we learn as we go. I mean, look at the current situation. I can tell you, nobody, if you asked 1,000 scientists on this planet, do you think that mRNA vaccines would cause myocarditis? That was a complete surprise. I mean, do you think that these vectored virus vaccines, like the Johnson & Johnson vaccine or the AstraZeneca vaccine, could cause a severe clotting problem that could be fatal and has been for about a handful of people? I don't think anybody would have thought that was possible. Why would that happen? So you have to be open-minded to that. So I think the one thing you have to learn, to me as a scientist, I mean, I was fortunate enough to be part of a team at Children's Hospital of Philadelphia that created the strains that became the rotavirus vaccine, Rototec, is humility. Humility has got to be the key, which is why early on in this pandemic, actually, when some of the CEOs of the companies like Moderna and Pfizer, when they were doing phase one trials involving 20 people, 30 people, and they started talking about how they could make millions of doses, you're thinking, don't say that, just be humble, because you don't know. Be open-minded and humble, because nature gives its secrets up grudgingly, sparingly, and often with a human price.
Do you foresee the time when children under 5 will get vaccinated?
Yes. So right now there's so the vaccines, the Pfizer vaccine, which is the farthest along, for those over 12 is given as a 30 microgram dose, 2 doses, 3 weeks apart. For the 5 to 11-year-old, it's a 10 microgram dose, so it's a third of the dose. For the 6-month-old to 5-year-old, it's a 3 microgram dose, so it's a 10th of the older adolescent or adult dose. Those studies are ongoing. I mean, we, the Vaccine Advisory Committee at the FDA, have been asked to set aside a series of dates.
I tried writing it out, and then I tried the website, but I didn't think of using the first 4 letters of the website without the .org.
Winona, I think that's Winona. You may need to.
Yeah. We're going to let Dr. Offit continue. I think we've got that quieted. Go ahead, Dr. Offit, please.
Yeah. So I do think we've been asked to set aside dates in January. I think it's possible we could be hearing about that in January.
As soon as January.
Well, you never know. You just know that what dates you've been asked to set aside. It doesn't necessarily tell you what they're being set aside for. So
okay,
we'll see.
All right. A question came in about whether people who work for the pharmaceutical companies can work sort of unfettered by the pharmaceutical companies, or is there any kind of interference in terms of what the pharmaceutical company might want to accomplish financially, politically, whatever?
Sure. I mean, I think sure. I mean, the pharmaceutical companies are making products to make a profit. I mean, that's their drive, is to make a profit. They're not a nonprofit, but there are systems in place to at least assure, to the extent that you can, that a vaccine is, in this case, safe and effective before approval. The thing that's confusing, I think, here was just looking at last year, the typical licensure process is a 10-month process, typically. These products aren't licensed. I mean, recently the Pfizer's became a licensed product, but they're not licensed. They're approved through something called emergency use authorization. The same process, which approved hydroxychloroquine last year for about 3 months. The same process that approved convalescent plasma for a few months. Neither of those worked. And that scared people. And I can understand where it could scare people. I actually wrote an op-ed with Zeke Emanuel in the New York Times last year that warned of an October surprise. I mean, what really worried me last year as we approached the November 3rd election is that President Trump would feel compelled to reach his hand into Operation Warp Speed, pull out a vaccine or two and declare it safe, even though it hadn't had the adequate follow-up for safety follow-up, which is 2 months. But the size of these vaccine trials, at least for the adult trials, is the size of any pediatric or adult vaccine trial. And the safety follow-up is the same, 2 months after the last dose. The only real difference is length of efficacy follow-up. I mean, when we declared Pfizer and Moderna's vaccines safe and effective in December, we had 3 months of efficacy data. So that's not typical for a vaccine. Typically, it's years.
Okay. There's a lot of messages out there that are from the anti-vaxxers, not just Aaron Rodgers, but others. Do you have any, I don't know, that you can do it in a single sentence, but anything that those of us who are pro-vaccine can say to those folks? I don't know that we can change minds, but maybe there's something that would be helpful.
Yeah. I guess I divide this up into two groups. And so I see there's physicians here on this call too. So you guys and gals know this as well as I do, if not better. I think that the euphemism is vaccine hesitancy. I wouldn't use that term because I prefer to divide it up into two groups. I think the first group I would call a vaccine skeptic. That's fair. I think you should be skeptical of anything you put into your body and anything you put into your child's body. If you look at the polls that were done, like the Kaiser Family Foundation polls before there was a vaccine, before last December, like September, October, when they asked the question, would you get a COVID-19 vaccine? Only 30 to 35% of the American population said they would. That's a skeptic. And if you'd asked me that question, I would have said, not till I see the data. I think if you asked any of the 18 voting members that sit around the table at the FDA Vaccine Advisory Committee whether they would have gotten the vaccine, I think most would say no, not until they see the data. That's a skeptic. Show me the data. So that then a few months after those vaccines came out, that 30% number went up to 65 or 70%. That's a skeptic. Then you have the remaining 25 to 30%. Who, despite abundant evidence that this vaccine is safe and effective, it's not absolutely safe or absolutely effective, but in the world of vaccines, it's highly safe and highly effective. That's a cynic, someone who just simply doesn't believe the data. They don't trust the pharmaceutical industry, they don't trust the government, they don't trust the medical community. I don't think there's anything you can say to them. I can tell you, they call, I get a lot of phone calls and emails from people, and I'd say 85% of the time I can identify what people are concerned about and answer their question. But there is a solid 15% of people who call me who are just not going to believe what I have to say. And as Neil deGrasse Tyson says so famously, if someone doesn't use reason or logic to reach a certain conclusion, reason and logic is not going to talk them out of it. And that's all you have on your side is reason, logic, data. I mean, you can't appeal to this notion that there's a vast international conspiracy to hide the truth.
For those people who chose to get the J&J vaccine the first time round, will their need for the booster be different than people who got Pfizer or Moderna?
Yeah, I would say this. I think were this not a pandemic, J&J's vaccine would have never been a single dose vaccine. Now, it was of value as a single dose vaccine, which is why it was approved. But when J&J did its so-called phase 1 studies, meaning so-called dose ranging studies, way back when, they knew that with that second dose that you got a clear boost in neutralizing antibodies. They knew that. So when they then came at the end of February and asked our committee, can we get approval? They were in the midst of a 2-dose trial because they knew what they saw from their phase 1 studies. And that trial was finished a few months after we met at the end of February. With their second dose, their efficacy approached the same efficacy as the mRNA vaccines, sort of 94% efficacy. I think the J&J vaccine was always a 2-dose vaccine. I think it was a value as a 1-dose vaccine, but it is a 2-dose product, with the second dose being given at least 2 months after the first, and then up to any time after that, but at least 2 months after the first dose. That said, if you've gotten a single dose of J&J vaccine, you can also be boosted with one of the mRNA vaccines. But I think J&J's was always a 2-dose vaccine.
Okay. I happen to have gotten Pfizer, so I knew what I was going to do in terms of Pfizer. For the people who got J&J, do they need a bigger booster? Can they expect more of a reaction when they get a booster? Is that a fair question?
No, it's a fair question, sure, but I don't think, either getting the J&J as a second dose or getting one or other of the mRNA vaccines as a second dose, but I think it is a value. In terms of the booster dosing, because this is the question I get asked most commonly, here's what I would say. What's the goal of the vaccine? To me, the goal of this vaccine, and frankly, the goal of any vaccine, is to protect against serious illness. That's the goal. Protect against the kind of illness that causes you to seek medical attention or go to the hospital or go to the ICU or go to the morgue. That's the goal of the vaccine. It's the goal of all vaccines. It's the goal of our rotavirus vaccine. These vaccines are good at that because the immunological component that's necessary to induce protection against serious illness is something called memory B cells. And memory B cells are generally relatively easily evoked, and it's true for all 3 vaccines, and are long-lived, meaning years. I would anticipate that protection against severe disease would be years for at least all but one group so far. The one group in whom memory does appear to fade over time are people over 70. That's true. I mean, the Israeli data were clear, and I think the data here are clear. So were I 70 or older, I think it there's abundant data showing that a third dose, if you've gotten 2 mRNA vaccines, is of value. The other recommendations, it gets blurred, because now you're not talking about protecting against serious illness anymore. You're talking about any nature of illness, meaning asymptomatic infection, mildly symptomatic infection. And I think where we all got sucked in, frankly, was, and by we, I mean CDC, I think where we got sucked in, we as a country got sucked in, was when we did the efficacy trials that were published in December, and you had 94% efficacy, 95% efficacy. That was after 3 months. So you've gotten your highest immune response. You've just gotten boosted a few weeks ago. So those data are going to look as good as they can look. And what will happen over time, because it's true of every vaccine, is neutralizing antibodies will start to come down. That's always going to be true. And therefore, protection against asymptomatic or mildly symptomatic infection will wane. That's true of every vaccine. I mean, it's true of the whooping cough vaccine. It's true of the flu vaccine. It's true of the rotavirus vaccine. The goal of those vaccines is to keep you from having serious illness, which they do, as this vaccine does. I think the biggest communications error associated with this vaccine and this virus was the Provincetown outbreak in July. I mean, so what happened there was, and it was reported in Morbidity and Mortality, it was reported over the media, and it was the birth of a term that I continue to regret. And I'll tell you what that term is in a second. So here you had thousands of men getting together in Provincetown, Massachusetts, 79% of whom were vaccinated. They're indoors, they're celebrating, many without masks, and an outbreak occurs. 346 people who had been vaccinated got COVID, 346. Now, most had asymptomatic infection or mildly symptomatic infection. 4 of the 346 were hospitalized. That's a hospitalization rate of 1.2%. The way that should have been carried in the media, by the CDC, by anybody who commented on this, was this shows you how well this vaccine is working. Because if you have a hospitalization rate of 1.2%, that's great. That's as good as you're going to do with any vaccine. Congratulations. Instead, what happened was the birth of the term breakthrough illness to apply to an asymptomatic or mildly symptomatic infection. That's not a breakthrough. That's a win. I mean, with Brett Kavanaugh gets 2 doses of his mRNA vaccine as he got, and then has an asymptomatic infection, congratulations. That's what's supposed to happen. You've won. You were exposed to the virus. The virus is reproducing itself somewhat in your nose and throat, but never causes symptoms. Or even Lindsey Graham. I'm not mean to just quote Republicans. It's working out that way, because you never really get a chance to do that actually when it comes to science or medicine. But so Lindsey Graham, right, fully vaccinated, gets a mildly symptomatic infection associated with mild sinusitis, and says correctly, quote, "This would have been much worse if I hadn't been vaccinated." Right, that's right. But we use the term breakthrough, which implies failure, and that's not a failure. That's a success. So now we're trying to do something else. Now we're trying to keep up the level of neutralizing antibodies with boosting. And so we now are pushing for this third dose. And it's just this sort of ubiquitous third dose. And so now everybody feels they're not fully vaccinated unless they get that third dose. I think when President Biden stood up and said in mid-August, we're going to have available to this country a third dose basically for everybody over 18, he said, he implied inadvertently, I think, and certainly, we're all trying to do the right thing, but I think what he inadvertently implied was that 2 doses wasn't enough, that you weren't fully protected with 2 doses, but you are. You are protected to date against serious illness with 2 doses. You are, with the exception of those over 70. I think that's the one group in which you can see fading. Now we also have a recommendation for anybody over 50 who has who has an illness that could put them at risk of severe COVID is also recommended. I don't think there's a downside. If you listen to the conversation, both at the FDA Vaccine Advisory Committee and the CDC Vaccine Advisory Committee, when it came to booster dosing, both of us balked. We both did. And that's why they have not brought this issue of Pfizer's wanting a vaccine for a booster for everybody over 18 back to those committees, because they know that if that came back to those committees, I think those committees would say no. And the reason that they would say no is the number 18. That's what upset both those advisory committees, me included. Just don't say 18, say 30 or 35, because the 18 to 29-year-old is at increased risk of myocarditis, which is rare but real. And there is I think generally it's a mild illness, which is self-resolving and transient, but not always. And I think unless you have clear evidence for benefit for that third dose in an otherwise healthy 18 to 29-year-old, I don't think an 18, 29-year-old should get it. My children are both in their 20s. I'm not recommending they get that vaccine as a booster. Also remember, the reason when you saw myocarditis, it's generally in boys and men, and generally after the second dose. Why the second dose? That's the booster dose. Now the third dose is an even bigger booster dose. So isn't it reasonable to conclude that you may also see myocarditis? That's what upset people. And just among us, I mean, I did talk to Dr. Fauci about this at some length, and we both saw it the same way then. Just, over 30, just say 30, say the number 30, and then this whole discussion goes away, but we didn't.
Okay, question. Where does natural immunity come into play?
No, I think natural infections, this is sort of the data are all over the place, but I think it's fair to say that if you're naturally infected, and I wish we had a different word than natural, because I'm not sure why Mother Nature has such good PR. I mean, because, she has been trying to kill us ever since we crawled out of the ocean onto land, but natural, somehow the word natural has become good. But in any case, the immunity induced by disease, which can be fatal occasionally, I think does induce the kind of immunological memory that can be long-lasting. It does probably to some extent depend on the nature of the illness. I think an asymptomatic infection is probably less likely to induce the kind of memory cells as compared to a symptomatic disease. But it is protective. I mean, if you look now, immunity induced by natural infection or immunity induced by vaccination, or both, because there's overlap between those two groups, you're probably at least 80% of the population that's there now. You are. And serological surveys of sort of blood bank material suggest we're at least at 80% population. I mean, what surprised me actually was, what percentage of 5 to 11-year-olds are seropositive? About 40%, which tells you there's a lot of asymptomatic infection out there in young children. But so I think it is a value. It's also clearly a value to get a vaccine, even if you've been naturally infected. I mean, you broaden your immune response against variants of concern. So it's clearly a value to get a vaccine even if you've been naturally infected. But if you've been vaccinated and then naturally infected, you're good. That was your boost. Forget it.
Okay. So you talked about age groups in terms of vaccination. You talked about gender. You had sort of referred briefly to the idea of people who are immunocompromised and let's say under 70. Those are the people who should get a booster, or depending on what their doctor says.
Yeah, so the term immune compromise is a broad term. There's all different levels of immune compromise. I mean, there's people who are get solid organ transplants, bone marrow transplants, cancer chemotherapy, or just biological agents for rheumatoid arthritis, et cetera. So it really depends on the nature of the immune compromise, because you can sort of, depending on what the agents that you're getting, either biological agents or cancer chemotherapy agents, you may be able to manipulate things so that you can get a boost at a time when your immune response is not as suppressed. You have to work with your doctor on this. I think there's certainly no downside. The good news about the mRNA vaccines or the vectored virus vaccines is they don't, it's not like replicating virus. Even if you have no immune system for whatever reason, and you get a live attenuated viral vaccine like measles, mumps, German measles, chickenpox, that can be dangerous for you. But that's not true with these mRNA vaccines. I mean, the mRNA vaccines just, make protein in your cytoplasm for a few days and stop. It doesn't matter whether you have an immune system that'll stop. It's just the way you make any protein. Insulin, hemoglobin, it's the same way you make any protein.
Okay, I'm going to ask you a very pragmatic question, because people I know have had vaccines, and now we're moving on to something else. You get invited to a wedding, and you're told that everybody who's coming to this wedding has shown a vaccine card and has been vaccinated. But when you go to the wedding, people go inside to eat and, of course, take off any masks they might have worn on the way there. Does that strike you as a safe situation? Let's say there are 150 people, or let's say there are 400 people.
Right. I think if you walk into a room, even indoors, I think that if everyone's vaccinated and everyone who's in that room has no symptoms, so vaccinated, asymptomatic, I think the chance of spread is very, very small. It's not zero, but it's very, very small. Although here's my feeling about the current pandemic. Get me to the end of February. I do, this is a winter respiratory virus. And if you look at last winter, and obviously we didn't have a vaccine really available till the end of December last year. So it's not completely analogous, obviously, but you really take off in November, December, January. It's by mid-February you start to see it come down because it's a winter virus. And I'm going to feel a lot better in the spring here with this. Our daughter's actually getting married in the spring.
Congratulations.
She's leaving us. No, that's all right.
Yes, well, it does happen. So can people get a false positive if they've had 2 vaccines and then a booster?
Well, sure.
If tested.
False positives are always possible. I mean, I think the vaccines aren't perfect, and natural infection doesn't provide complete protection always either. So, sure. I mean, the PCR test is a very sensitive test. This is a weird virus, and if I can explain this, the better test in a sense is the antigen test, like the Binax test, because that's a little closer to the fact that you're shedding infectious virus. The PCR test is just viral genome. And what's weird about this virus that nobody really ever talks about, unless you listen to the show This Week in Virology, the virus reproduces itself, and then you are shedding infectious virus. You are contagious for 7 days, 8 days, 9 days, something like that. But you can be PCR positive for 3 months. What this virus does that no virus that I know does is it continues to make genome, but doesn't make whole virus. And the way it continues to make genome is that its genome, the gene which is the blueprint for how it reproduces itself, is messenger RNA. I mean, it's so-called positive sense RNA. And that's very labile. That's a labile molecule, so it breaks down at mucosal surfaces. The fact that you're still positive for 3 months tells you that the virus is still making genome, but isn't making whole virus. So you're not contagious, but you're genome positive, which is why I feel sorry for people when they say, you have to wait till you're PCR negative, because could be for 2 months where you're not shedding infectious virus at all. It's just weird. The virus is weird that way. I know of no other virus that does it.
We had several questions about masking. One question was, do you think people will be masking indefinitely? Number 2, are there going to be masks made for very young children so that it will fit better on their faces? And do you think that masking in schools is the right way to go? Because there is a certain amount of, I don't want to say feeling, but there are movements of people saying, oh no, the kids in classrooms should not be masked. What do you think of the masking situation generally?
I think if you look at who's vaccinated, the highest percentage of vaccinated people are people over 65. I mean, it's like 90%. If you go to 10-year increments and just keep going down, right? 50 to 60, 40 to 50, 30 to 40, it drops each time you move down. If you look at the 12 to 15-year-old, for whom vaccines have been available for months, the percentage of that population that's vaccinated is 45%. So more than half of people 12 to 15, despite the availability of a vaccine, have been vaccinated. I suspect that for the 5 to 11-year-old, it will be even less. I mean, I'd be pleasantly surprised if 25% of 5 to 11-year-olds got vaccinated. So I think that when you go to school, know that you have an under-vaccinated population. Know that the virus is still circulating, especially in the winter. Know that you have a group of susceptible people all in one place. I think masking is the only thing that makes sense right now until we get past this, at least for this, especially for the winter. Just get us through the winter. That's the problem. It's a winter virus.
Well, we just heard a story of a child who went to school with COVID and managed to infect 30 other kids in the school. That's a big number, it seems to me. It shows the power of the virus, and as you call it, a susceptible population.
And the parent knew that the child had COVID.
And the parent knew.
Good Lord.
It's a little mind-boggling, isn't it? Okay. Are you suggesting for those, what do you think? We talked about vaccines, we talked about masks. What about isolation? People who are, let's say, over 70. Should those people continue what this person calls safety isolation after the end of February? Or just see what's happening in February and how the charts are going in terms of
I think we'll see how it goes. I mean, I just think we'll see how it goes. I mean, I think, if someone's visiting me, I'm 70. If someone's visiting me, I insist they be vaccinated. I'm not gonna. I mean, we went to dinner last night we went over to a friend's house for dinner. I would never have gone over there unless I knew they were vaccinated. So that's clear. Then they're both vaccinated, both asymptomatic. I felt comfortable sitting around that dinner table without a mask. But if ever I go indoors, if I go grocery shopping or whatever, I'm always going to wear a mask. I think another thing the CDC did, and I wish they hadn't done it, was, and I think they did it naively, really, that they said, look, if you're vaccinated, you don't need to wear a mask. Remember, they said that a few months ago. I mean, it puts a lot of trust in the population. I mean, if I go into the Acme, for example, around the corner, I have to trust that everybody who's not wearing a mask is vaccinated. I think probably the opposite is true. So I wear a mask.
Would you go into a restaurant and have dinner inside a restaurant?
Yeah, I will. I'd like to believe that I'd like to see that the servers are wearing masks because they come closest to me. I'd like to see at least I have 4 feet between myself and somebody else who's sitting there. I know that many there, or some may not be vaccinated, but I do feel comfortable sitting there across from my wife, one table, servers that are masked. I'll do that. I think we're getting there. When do we feel comfortable? I can tell you that this virus isn't going away. We're going to be dealing with this virus for years, if not decades, because remember, we still give a polio vaccine in this country. We haven't had wild type natural polio in this country since the 1970s. We still give a polio vaccine because polio still exists in the world, really in only 2 places, which is Afghanistan and Pakistan. But if we let our guard down, if we don't have a fully or a highly protected population by vaccination, that virus could come back. And so do I think that this virus is going to be existing in the world for a while? Yes. And I really do wish that instead of the booster dosing, I mean, I keep going back to this, either that we had invested more money in testing and allowing, my sister came in from England to visit us the other day. I mean, she had a whole package of these essentially antigen tests that are given to her for free by her government. So if she has a symptom, she'll instantly test herself and know. I mean, that or do what we really need to do. It's not boosting them. I mean, we're not, as Rochelle Walensky, the head of the CDC, said, we are not going to boost our way out of this pandemic. And that's right. I mean, you really have to vaccinate the unvaccinated. Is going to have a much bigger impact on this pandemic than boosting the vaccinated. And again, I just think that I really wish we have a bigger commitment to the world. The Moderna contract was a bad contract. I mean, I understand the Trump administration wanted to own this exclusively, but I just think it's very short-sighted to think that what happens in the rest of the world doesn't affect us. I mean, isn't that at least the lesson of this pandemic?
Do you
Also,
think
one other thing, Lenore, just one thing. So we're now seeing immigrants and refugees from Afghanistan in our hospital, children. Only 1 of every 200 people who are infected with polio have paralysis. I mean, that's an asymptomatic infection for the most part, or a mild GI illness. And it's interesting to see the way our residents are handling this, right? Because now for the first time, they're thinking, could this child be excreting polio? They're coming from a polio endemic region. It's interesting to see how fear works.
That's a tough one. Do you think that at some point getting vaccinated for COVID will be an annual thing, like getting a flu vaccine?
If the goal of this for this vaccine is to keep up your neutralizing antibody titers, which is a goal of no vaccine. I mean, we don't do that for vaccines. Then it will be true. But that's not why we vaccinate with flu annually. We vaccinate with flu annually because the virus changes so much from one year to the next that natural infection or immunization the previous year doesn't protect you against severe illness. That's not true here. I really do think an otherwise healthy young person is going to be protected. I would predict for years. We'll see. I mean, Dr. Fauci is of the belief that had we not been in a pandemic, the mRNA vaccines would have been 3-dose vaccines with at least 2 of the doses separated by 6 months. That's his belief, and he may be right. I mean, we'll see what happens. But for right now, all the evidence is that protection against serious illness is holding up. That's the data the CDC continues to publish and continues to present at national meetings.
A question was asked about fluvoxamine. Someone said, why are doctors so slow to come around to treating this COVID with fluvoxamine? I have not even heard of that. But
I mean, so they're like molnupiravir and molnupiravir. I mean, they're antivirals. The thing about antiviral, first of all, remember, an ounce of prevention is worth a pound of cure, right? Ben Franklin, Penn. It's much better to prevent something than try and treat it. See, as a Penn person, you're supposed to mention Ben Franklin at least once every time you give a talk. Okay, so I'm good. But I think it's, like we're just so excited, it's like 50% effective at keeping you out of the hospital. I mean, the vaccines are like 90% effective plus at keeping you out of the hospital. So get vaccinated. And also remember, for antivirals or monoclonals, they don't work later in infection, because the way that the infections, all infections work, is that initially the virus enters your nose and throat, begins to reproduce itself, then it reproduces itself more and more and more and more. Then what happens is your immune system starts to kick in. As your immune system kicks in, that's when you develop symptoms. And when you develop symptoms, then you're having less and less viral replication. So it's the immune system that is really causing the symptoms, which is why drugs like dexamethasone work, or these monoclonal antibodies like tocilizumab work. I mean, anti-immune system drugs. There's a new JAK2 inhibitor, beta-citinib, which is now being used in our hospital more. These are all anti-immune system drugs, because that's what you're treating really at that point. Antivirals, by the time you get to the hospital, by the time you're sick, don't work. Same thing with monoclonal antibodies. So that's it. It's you're really talking about treating somebody early on, very early on in infection, and that's why they, I think, to some extent, are limited.
Okay. You talked about how the outbreak as a result of the Provincetown gathering was treated in the media. Is there any way to educate the media so that it will cover things in a way that tells the accurate story to the public? Or is that just not going to happen because the media likes to make things more dramatic always?
I think you should just ask Ted Tapper to do that.
I know, I was giving it doing a softball for Ted. Okay, a question about your book. The question is, how did you decide which innovations to include and what others might you have included if your book was going to be longer or perhaps a second book on a similar topic?
Right. So it includes the 9. I picked 9: blood transfusions, transplants, X-rays, anesthesia, chemotherapy, gene therapy, biologicals, antibiotics, and vaccines. I guess my sense of, in terms of, we live about 30 years longer than we did 100 years ago. And the question is, what were the things that most likely contributed to that extension in age? And those were the big ones. So that's why I picked that. I don't regret. No, there's nothing I can think of that I would have wished I'd included.
Okay, fair enough. And are there more studies going on now that young people are getting vaccinated to find out about the long-term potential side effects of the vaccine with them?
No, that's always, see, the good news is that that there are systems in place, like the Vaccine Safety Data Link and the so-called PRISM system of the FDA, which are in place so that you very quickly to determine, using a sort of rapid cycle analysis, who's gotten the vaccine, who hasn't gotten the vaccine, is there a side effect? When you see something like myocarditis, which is a cause which is a consequence of the mRNA vaccines occurring, depending on what age group you look at, 1 in 40,000 people, 1 in 50,000 people, that tells you that those systems are in place. And look at the J&J vaccine. I mean, that as a cause of severe blood clots is roughly 1 in 500,000. I mean, obviously, those are not going to be things you pick up pre-approval or pre-licensure. Those are only going to be picked up when you're in millions of people. But those systems are able to pick it up. That should make people feel much better that nothing's going to slip through. And your earlier question about should we really trust pharmaceutical companies, the fact of the matter is you don't have to, because they're not going to sneak something by that has a side effect that they were covering up that won't be picked up post-approval.
Is there any possibility that people who cannot be vaccinated could be infected by people who are vaccinated?
Yes, absolutely. I mean, there's estimated about 3% of the U.S. population is not going to be effectively vaccinated. It's 9 million people or so. And so, to me, when people ask me what is the worst thing anti-vaccine activists say to you, aside from when they curse at me or threaten my life, I think the worst thing they say to me is, what do you care what I do? You're vaccinated. Well, that makes 2 incorrect assumptions. First, that vaccines are 100% effective, true of no vaccine. And the second, that everyone can be vaccinated. I mean, do you have any responsibility to your neighbor? Do you in any sense want to be part of society where you have a responsibility to that society? I mean, there was in California, years ago, there was an outbreak of measles. It centered in Southern California, in the Disneyland area, with this generally sort of liberal group of, all things natural. I don't want to get vaccinated. I just want things that are, free of, bisphenol A and gluten and dolphins or whatever. So therefore they didn't get vaccinated. The group didn't get vaccinated. So there was a measles outbreak, spread to 25 other states. So a guy named Richard Pan, who was the Democratic state senator from Sacramento, wanted to eliminate the philosophical exemption. Now, it's a state that never had a religious exemption to vaccination for school entry. So he wanted to eliminate the philosophical exemption because that was the birth of school mandates, was to try and prevent measles. This all started in the 1970s, and we did it. We basically eliminated by 2000 measles from this country. It's come back to some extent because a critical percentage of parents have chosen not to vaccinate their children. But we did eliminate the most contagious of the vaccine preventable diseases with those school mandates. So in any case, during those hearings, I mean, the anti-vaccine people were really angry. There was a little boy who testified at those hearings whose name was Luke. And I have pictures of him, but not a videotape of him. I really wish I had a videotape of him. And what he would do is they would put him on a chair where he could reach the microphone because he was only 5. And he had leukemia. He was in the midst of his induction phase for his chemotherapy for leukemia. And he said, "What about me? I depend on you to protect me. Don't I count?" I mean, he was the voice of society. They really didn't have a counter to him.
It's pretty dramatic. Do you have any thoughts about your next book?
Yeah, I thought I'd write a book about the pandemic because I'm thinking nobody's going to write a book about this pandemic, right? It's like such a niche market. I thought, no, I might write a book that has to do with how horribly we've been misled. Just in terms of the anti-vaccine information. If you'd asked me years ago whether I thought that in the midst of a pandemic like this one, where we've been brought to our knees, just the joblessness and homelessness and food scarcity, food insecurity, et cetera, that if you had a vaccine that works as well as this did, that the anti-vaccine movement would shut up and we would realize that they're only hurting us. Not true, not true. And I think, to me, I'm trying to make sense of this. The conspiracy reigns. It does. I mean, Tony Fauci is responsible for this. Bill Gates is responsible for this. The Wuhan laboratory created this strain, which is absolute nonsense. That there's, that vaccines, that the numbers have been manipulated, that there's really not that many people who've died. All this sort of conspiracy theory nonsense. And I think what I've come to see is that there's two narratives. And the narrative that in many ways is initially the most persuasive is the conspiracy theory narrative, because a pandemic is chaos. You don't know it's not clear where it came from. It's not clear initially how it was spread. It's not clear initially with the masking. It's not clear whether or not how a vaccine was going to work. All that was up in the air. We didn't know. What conspiracy theories promised or offered was a narrative. Here's how it started. Here's who's behind it. Here's what's going on. There's healing microbes in the ocean, so they shouldn't close the beaches. Masks don't work, so we don't need to wear a mask. Vaccines are dangerous, so don't worry about the vaccines. They're overrating this, so don't worry about that. I mean, that's a narrative that was seductive. It told people what they wanted to hear. Now, the science will also create its own narrative. I mean, we will realize where the virus came from eventually. We will, and we'll realize exactly how it spread, and we'll realize exactly what we should have done differently. But that narrative comes slower. I mean, you could make the same argument for Andrew Wakefield claiming that the measles, mumps, rubella vaccine caused autism. He provided a narrative that was. That's Jane.
Adam, can you mute
Hi,
that,
Jane.
please?
I'd like to include, they look so nice on you, are they real?
Adam, maybe you can mute that?
They look so good.
Okay, so what Andrew Wakefield provided was a narrative. Autism was chaos. You don't know what caused it. You don't know how to treat it. You don't know how to cure it, how to prevent it. He provided both. Here's what caused it, MMR vaccine. Here's how you prevent it. Don't get that vaccine. I mean, that's what makes that so.
They look so nice on you. Yeah. Are they comfortable? Yeah.
David, can we get that muted?
There it is. Now you got it.
Okay, thanks. Okay, we'll go back to Paul. Sorry, everybody.
That's right. No, I just think I'm intrigued by that, by the fact that, people used to always say, well, we just need a good plague and everybody will understand the importance of vaccines. Because, I mean, you didn't have to convince my parents to get vaccinated. I mean, they saw diphtheria as a killer. I mean, they were children in the 20s. I mean, they saw diphtheria as a killer. They saw polio as a cripple. You didn't have to get me to get vaccinated. I had measles, I had mumps, I had German measles, I had chickenpox. I had those diseases. I mean, you don't have to convince me to get vaccinated. But my children grew up at a time where not only did they not see these diseases, I think we've eliminated not only the disease, but the memory of these diseases. And I think that's where vaccines suffer. And I'm intrigued by the capacity of conspiracy theory to reign the way it does.
Okay. Okay. if you think that the Wuhan origin of this virus is nonsense, do you think that there's enough known yet to know where it originated? Or you said it's going to take time for all the answers to come out?
No, I think it
there any-
originated in China. I mean, it certainly originated in the Wuhan area. That original strain, the so-called WU/2020 strain, that is not that far from bat coronavirus. I mean, it's probably about a 20 to 80 year evolutionary chain that would have explained that transition. I mean, that's true of many viruses. I mean, you know, the human immunodeficiency virus mutated from simian immunodeficiency virus, probably in Cameroon in the 1930s. I mean, there's a lot of viruses. I mean, Ebola, you know, there's flu is a bird virus. You know, we live in close association with animals, and so viruses can mutate to infect us. And I'm sure we will figure out exactly how that happened in that area of Wuhan. And it may certainly have to do with those wet markets at some level, but it was an evolutionary process over time. It wasn't that long for this out. But you know, this is the third pandemic strain in the last 20 years. You had SARS-1, then you had MERS, and now you have this. So, you know, I mean, the notion that it was created in a lab is just silly. First of all, I mean, well, without getting into too much of the virology, the binding, when a virus attaches to cells, a virus has to attach the cell before it enters the cell. Always true. The attachment protein for this virus is actually not that strong. It's not something I think anybody would have intuitively made. It's just, I don't think a person made this.
Someone asked about the Binax test, said you mentioned that. Can you tell about the accuracy of that and the utility?
You
of
know,
it?
that's an antigen test. I think it's reasonably accurate. Yeah, I think that's right. And so it's an antigen test, which is, antigen means the protein, meaning viral proteins. You know, viral proteins being made. So it's not just a genome test. So I think it's a little closer to the likelihood shedding of infectious virus than say would be the genome test.
I think I've gotten through just about every question. Dr. Offit, thank you very much for being with us for this. Thank you all for watching. You can see this on the LMLS, Lower Merion Library System website, our YouTube channel. You'll be able to click on that. So for your friends who didn't get here today, they can watch it at some other time. Also, I'll give a little plug for something else, which is that last year in the midst of the pandemic, I did not have I also run the library show on Lower Merion TV, and I had every show featured a local author, local to the Philadelphia area. And those shows are all on the LMLS website now. It'll say LMLS on LMTV. So for those of you who like to see authors, like to hear what they have to say, there's another way to do it. Dr. Offit, you've had the pleasure of spending time with him today. Thanks so much for being with us, and I hope you come back to One Book, One Lower Merion next year. Thank you, Paul.
Thank you, Ez. Bye-bye.